Section 3. Chemical Names and Formulas. Chem Talk. Forming compounds, ionic compounds. There are certainly more than 100 physically different materials in this world. With approximately 100 elements, how is it possible to have such a variety of materials? How is it possible to invent new materials for clothing, building, and food? Elements can combine to form compounds. A compound results when two or more different elements bond. Some compounds are made of positive ions and negative ions that are bound together by the electrostatic attraction of opposite charges. An ion is an atom that has lost electrons and become positive, or an atom that has gained electrons to become negative. This is in accordance with the octet rule. For example, when a potassium atom loses its one valence electron, it takes on a charge of positive 1 and becomes a cation, or potassium ion K positive. A cation is any positively charged ion. Both the potassium atom and the potassium ion contain 19 protons in the nucleus. However, the potassium ion contains only 18 electrons in its orbitals, one less than the potassium ion. This is the reason for its positive charge. Where does this electron go? It must be accounted for. Typically, a nonmetal such as iodine will take up this electron to become an anion. An anion is any negatively charged ion. Iodine takes on the electron to fill its outer valence shell and becomes the iodide ion. Iodine and iodide both have 53 protons in their nucleus, but iodide has one more electron in its orbitals than iodine. The 54 electrons give iodide a net charge of -1. The resulting ionic compound is potassium iodide, right here. Small amounts of potassium iodide are added to most common table salt to provide iodine as a dietary supplement. Common table salt, or sodium chloride, is another example of an ionic compound. Okay, so that's the common name, table salt. There's your chemical name, sodium chloride. There's your chemical formula right there. Is another example of an ionic compound, table salt. Okay. All right. Naming ionic compounds. If you refer to the periodic table, you will notice that elements that form cations are metals on the left side. Most elements that form negative ions are nonmetals and are found on the right side of the periodic table. Metals combine with nonmetals to form ionic compounds. To name binary ionic compounds, the positive ion of the metal comes first and its name is unchanged. The negative ion is named second and its name is changed to end in "ide." In the example given, potassium and iodine will react to form potassium iodide. When ionic compounds are dissolved in water, you find that the ions conduct electricity through the solution. The term electrolyte is used for a substance that conducts electricity when dissolved in water. Polyatomic ions. In this section, you also investigated some compounds formed with polyatomic ions. Polyatomic ions are made of two or more atoms that are covalently bonded together as one particle with a charge. In covalent bonds, the electron transfer is incomplete and the atoms share the valence electrons. For example, some antacids contain magnesium hydroxide. chemical name, chemical formula. Being in group 2A, magnesium takes on a charge of positive 2 when it loses its valence electrons. The hydroxide ion, OH negative, is an example of a polyatomic ion. It has a net charge of -1, so it takes 2 hydroxide ions to make the compound neutral. Hydroxide is a common anion in all ionic bases. The following table lists some. Okay, we'll get to the table down here. Okay. The following table. Guys, where was that? Hold on, let me pause for a second. Okay, here we go. Hydroxide is a common anion in all ionic bases. The following table lists some polyatomic ions, their formulas, and their charges. It is important to realize that when a compound containing a polyatomic ion dissolves in water, the atoms of the polyatomic ion remain bonded together and the charge does not change. There's your table. Naming acids and bases. Many acids and bases contain a polyatomic portion that, when dissolved in water, retains its identity. However, each acid forms hydrogen ions and each base forms hydroxide ions. The naming of most bases follows the same rules as for the naming of ionic compounds: metal, then hydroxide. So you have your metal first, and then you have your hydroxide. For example, calcium hydroxide is CaOH2, meaning that you have your metal and then you have your hydroxide. Acids are a bit more difficult because each has its own name. The following table lists the common acids, their formulas, and their strengths. To write the formula of most acids, the acidic H is written first because it will become the cation in water. After the H, the anion is written. Okay, such as nitric acid is what they're saying, where you have the cation written first, and then you have the anion written after. Okay, so that's what they're referring to when they said such as nitric acid. All right. Acids that contain carbon are called organic acids. These typically are weak acids, such as acetic acid, the acid in vinegar. In organic acids, the acidic hydrogen atoms are written first, followed by the number of carbon atoms in the molecule. The rest of the atoms contained in the molecule are listed alphabetically. Another example is formic acid, the acid that ants use as a defense agent. Molecular compounds. You also learned about molecular compounds in this section. When a molecular compound forms, two atoms come together, but neither atom gains or loses electrons. Instead, the bonding electrons are shared between the two atoms. The mutual attraction of two nuclei for a shared pair of bonding electrons is called a covalent bond. Molecular compounds usually are formed by non-metal combinations of elements. For example, water, ethanol, and carbon dioxide. So you have nonmetals combining with nonmetals. You would find that having no ions, molecular compounds do not conduct electricity well when dissolved in water. These are called non-electrolytes. This property of non-conduction is typical of molecular compounds and separates them from ionic compounds. With covalent bonds, you also may find that it can be useful to imagine that the atoms inside of molecules are charged. These imagined charges are called oxidation numbers. In both ionic compounds and molecular compounds, the atoms achieve a stable state. The atoms achieve a stable state, similar to the noble gases.